Hi everyone, it's Marta from Data Art, and thank you all for coming today. It's our third online Node.js meetup. And today we have a special guest, Alex, and who actually is the initiator of this community in Wrocław and currently living in beautiful Amsterdam. But I will not steal the thunder from our current leader, Cezary. So Cezary, please tell us more about today's meeting.
Yeah, I will also just give the voice to Alex because he's also the initial organizer. Just keep this community going, and it's very nice that we have the 7th meetup. All after all, yeah, it's see, everything is getting better. I hope the next meetup will be organized also partially in the office. I hope it will be possible, but right now, I really have nothing much more to say. So just Alex, keep going with your presentation and giving the voice to Amsterdam.
Thank you for introduction. Hey everyone, my name is Alex, and I'm really happy to have a chance talking to you. I had a chance to live in Wrocław for 2 years in the past, and it was really great experience, which I'm kind of missing. And I decided that it's probably a good opportunity to have this chance and use this chance to talk to you. And I got some stuff to tell you, and I'm gonna talk about making things easier. Probably read in the introduction of this talk that this talk was inspired by the conversation with one of my friends, where he told me how he started working on his project, where he built really wonderful infrastructure on Amazon Web Services, and he told me like, oh, you just have this instance, you have a database there, you initiate the events bus there, so your microservices can communicate, and it is indeed beautiful, and of course, there is no anything bad I can say about it. Of course, most of big applications have similar architecture nowadays, and of course, it's proven to be effective. But today, let's talk about smaller apps, and do we really need it for building small apps? Before we go further, I need to tell you a little bit about my background so you can understand why I've chosen Node.js, why I'm doing it with Node.js, and just get my motivation a little bit better. I'm working with JavaScript for last 6-7 years, and apparently when you work with one language full-time, it becomes much easier for you to express your thoughts in this language. And you kind of becoming this hostage of the situation when you want to solve small problems with the language you know, and apparently this language might become a JavaScript. I tried to switch to different languages for my personal projects. I have been really passionate about Haskell for a long time. I did functional programming with Elixir a little bit, and it all felt really amazing. And I felt that, yeah, those tools are really good tools. But still, in the end of the day, when I had to code something small, I've been opening Node.js and doing stuff just because it's so easy and intuitive for me to do it. I want to ask you a question. How much does the infrastructure of your pet project cost? Like, if any of you have pet projects, how much do you spend on them? And if there are any comments, I'd ask Cezary to comment me because I can see browser window now.
Yes, so we have the delay. So from my perspective, it could be a cost of, I don't know, one developer per month. So the salary of single developer. That's how I could estimate it from my experience.
So the point of this talk is to explain how I personally build projects and host actually dozens of the projects on small VPS servers, which I pay in total 16.80 euros a month, which is actually almost free considering the output I'm getting out of it. So since it's presentation in 90s style, I'm gonna go 90s. So let's focus on the simplicity. Again, the goal of this presentation is not to tell how we can build big applications, but how we can do something smaller. So we talked why nodes, and there are other reasons why you probably want to choose nodes. Node is kind of really expressive in the way how you can scaffold the application. It doesn't dictate you what you need to put in any folder. It doesn't dictate you how you want to start your app. It gives you total freedom. You can put whole application in one folder, in one file, and it's actually going to work. You need just Node.js executable to run it, and you can decide completely on your own how you're going to handle sessions, how you can store data, how you compile it, because you actually also want to use, probably want to use nodes on functional services like Amazon Lambda or similar. So probably will pre-compile your Node application so you don't install dependencies every time your Lambda is popping up. And you can also deploy it as you wish. And since it's really flexible and doesn't require many external dependencies, just Node.js runtime, it's really easy to run everywhere you want and in any way you want. We will focus on it on the platforms, and I have a couple of interesting examples with numbers for you, but let's go to the next slide. Of course, it's about compromises, and the goal of this talk is to show what we're gonna reach if we'll completely compromise scalability. So we'll keep the perspective of building the quality code. We'll try to have nice coverage code which can be supportable, which you will maintain, and to, like, next day after writing the code, you wouldn't feel like, oh, what the hell I just wrote. So we want to build something what you can support, maintain, and till the some points when you understand, okay, now I need to have some adult stuff, so I will write properly. I choose proper tools, proper technologies, proper deployment stack. So until that moment, you want to have something predictable and easy to support. So it's how we're going to do so. Let me tell a little bit case studies, what I personally use Node.js apps for. I have some business background, lastly, and I've been getting some investments from European Institute of Technology. And I had 2 projects participating in there, one of which was in the mining industry. We were trying to optimize the grinding mills with machine learning, and we actually run Node.js application on Raspberry Pi, and yeah, apparently you can do so. And even Raspberry Pi Zero, which is like 500 megabytes RAM and really big processor, actually it can run Node.js application. Also, I have a project which is still alive regarding the medical research, so you can upload your raw DNA data and see which diseases you may get and stuff like this. I wouldn't go deep into it, but still it's something what I do with Node.js, and it's something what allows me to prototype and iterate my ideas quickly, deliver to the stakeholders, show like, okay, guys, it's something what we can do, and is it okay or not? So I can try to adopt this business approach, which says fail fast and proceed quickly if I'm doing something wrong. So I don't have to invest many efforts into building something what isn't actually needed. I also have Node.js applications which automate my life and make my life easier. Since actually I gave quite a handful of talks, I wanna see if there are any questions from other people, and I'm trying to answer all the questions which follow up after the events, after the conferences. And actually checking it manually, it's not the good thing. So I have my small project with dashboard, which checks once a day if there are any new comments on YouTube. And it's just like 50 lines of Node.js code, but it really saves my time. Also, you can automate your photo collections. It's also something what I'm doing. I'm just checking which RAW files from my camera I edited, which ones I removed, and I just remove the same JPEG files and stuff like this. Chatbots. In the past, I had a project with chatbot for places in Wroclaw, for Telegram, so you can send your location and it gives you open restaurants with certain criteria you wanted. So all this stuff is really easily done with Node.js, as well as not Node.js runtime apps like Electron, which might be also a subject of this conversation, because this architecture and the ways how we're going to work with data is also applicable to Electron. I want to focus on the fact that we are not going to build something really shitty, but we'll try to build code which is good enough but not scalable. And for these purposes, I think that the core of our thinking should be how we make this code predictable, reusable, and how we test it. And thinking about tests first defines the way how you're gonna build your architecture of your app. Since this conception might affect the way how you scaffold your application, how you start splitting it into modules, I suggest starting from tests first. Of course, it's really good to have test-driven development process, which is really nice but expensive. And I wouldn't argue that for most of you and actually for me, honestly, as well, it's not always the option, but having some couple of basic tests for the very beginning might be a really good starting points to understand how you want to build your app. There is a nice tool for end-to-end tests, which is called Cypress. If you are building something with UI, you can cheaply test the behavior just by writing some end-to-end test with Cypress and test it as a whole, test some basic user flows, and make sure that at least like some basic functionality isn't broken. It will help you to prevent the situation when you push something and it kind of completely destroyed your app and you don't know about it. And after a couple of hours or in like even days, you realize that your app was down, or people who went to your website didn't register because registration form was completely broken. And those are not theoretical problems. Those are real cases which might happen for you, and they are actually happening. So having some tests which might be done on low cost but cover at least basic cases, user flows, is a really nice thing. You can also test your UI with Cypress. I wouldn't focus on it because still we are Node.js meetup. And contract testing, you can do it in various ways. There is Node.js packed plugin, but I wouldn't elaborate on it as well because I don't think I'm the most competent person to talk about contract testing. So how to? I said about tests, and let's assume we imagine that we're gonna start from tests. What we're gonna start from? First, let's think about functional programming a little bit. Don't run away thinking, oh no, it's gonna be one more talk about functional programming. No, but functions might be a good starting point for writing your boilerplate for your apps. Why? Because pure functions are really easy to test. When you write tests, you can just export your pure functions, import them in a test file, and run a couple of just tests for the function, and you just change different arguments to the function. You check what the output is, and you don't have to do any dependency injections. You don't need to fake middlewares, and you don't need to worry about different and complex mocks. Sorry, guys, I got a rain. I was presented as a person from sunny Amsterdam, and you can see how sunny it is. So, per functions, immutability. It's really hard to test functions which mutate the state, which have side effects, and it's fine if the side effects are, for example, some records to the database or events which are thrown or something like this. But if those side effects are effects for data structures, for mutable data structure, it's really hard to test. And if you have test which passes on the first run, but wouldn't pass if you run it straight away with the same app, with the same arguments straight afterwards, it can make a big room for uncertainty, and think twice if you want this. Pipe streams, it's actually a good way how you can work with data. And a little bit the way how we're gonna work with data in our examples, we will have small example today, we'll be focused on it as well. But again, it's not the main focus, but something that really helps me personally to build better apps. Monads, I'll also show you how you can compose compose functions, since of course there is no silver bullets, and when I tell something like, hey guys, use pure functions, you need to think that you need to understand that pure functions are going to be like 10 different functions, and you want to compose them. It's going to be another function which just iterates one after another, puts results into intermediate variables, or you just call function which accept another call of function as an argument, which accept another call of function as an argument, and stuff like this, which is kind of hard to read often. And if you use monads or monad data structures, it really helps you to kind of structure your execution of your function. So it's more about function composition, but not about figuring out how to work with types or something like this, what is also a case for more adult languages, if we can call it like this. And decomposition, as more code you will split in the very beginning, as easier is gonna be to support it. About monads, before we proceeded further, I gave a talk about monads, explaining monads with paper cups and putting candies into paper cups in Vienna. And I still think that this one might be beneficial for you if you want to know more about monads, but you don't need to watch it for the sake of this video, but just for further readings if you want to know more about it. So we said about pure functions, reusability, and what is it all about? First of all, you would probably want to split some pieces of code to reuse in multiple applications. What I discovered for myself, that code I write for my pet projects is often needed in another pet project. And what I started doing at some point, I just started having snippets. Afterwards, I realized that, okay, snippets aren't something what I really want to use. It makes me feel pretty uncomfortable, frankly speaking, and it's hard to reuse like this copy-paste. It's not as good, and afterwards I might discover that one of my snippets is actually not as good, and its behavior was full of bugs, and I want to fix it. And then you have to copy paste it to all projects. So afterwards, I started having additional repositories for reusable pieces of code. I started creating libraries, and you can have your private npm packages. You can have private Git repositories where you just put your packages and import stuff from. And you can use npm link if you don't want to publish your private package anywhere else. And you don't want to use any like paid solutions for having some personal Git, no, sorry, not Git, npm repository. You can just link to another folder and reuse package. And it's something what I personally do. I have a couple of Git repositories which are pulled in my directory, and I just link them with npm link. You can also manage a couple of repositories inside. And a couple of npm packages inside one repository. There is a library which is called Lerna, and it allows you to imitate imports from npm, but actually using packages which are located in the same folder. What you want to probably reuse is file system operations. I got at some point, I understood at some point that operations like reading from files, writing to files, encoding files correctly, cleaning data before saving it, parsing CSV files, parsing images, processing resizes of images, checking if there is such image already, checking if you have similar text in files, is really an operation you use frequently, and not all of those tasks are as easy to do. For example, checking similarity of text might include some complex things, like comparing the proximity of strings. And it's not as hard to implement, but you can automate it and do it once and just reuse afterwards. API requests, I got a personal library which just goes to different websites and scrubs data from them. And so like this process of fetching different APIs, of sending my personal cookie or JVT token and stuff like this, I just made a library which encapsulates it all for me. as I said, page scrapping. There is a lot of things to be automated, like get me text from this div, go to another page, listen to some changes and stuff like this. So if you use something like Puppeteer, it's gonna be also really useful for you to throw it away from the project and put it in some reusable component. And yeah, the last one is data population and extraction. I have some personal packages which I import and reuse for the stage where you received some data and you want to put it into database and you want to prepare it, you want to clean it up properly. And when you work on different projects, you develop some patterns of working on different stuff. And you repeat yourself, and at some point you understand that some pieces of business logic are also similar. So yeah, that might really be helpful. So today, together, we are gonna build a successful startup. A couple of minutes ago, I drew a logo for it because we are really successful and we need a logo. So we'll count amount of seals together. So let me switch to the code. First of all, let me tell you what I already prepared here. So you wouldn't be surprised what we use. In the first place, I will comment what Node.js is later. I have package.json, and I just defined the list of packages which we're gonna use today. So I wouldn't do npm install during our examples. I will use the following packages: artillery for performance testing, bcrypt for encryption and decryption, body parser, which will help us just to get JSON out of requests, Express.js, obviously JSON Web Token, WowDB, monads for monads and function composition, but this one is just my personal preferences, and I have no arguments for it, and I don't think I should promote it. And short ID for generation of unique IDs, since we will use a database which doesn't generate IDs on its own. So let's create an index. It's gonna be the only and primary file we were gonna work today on. And here we will create the application. It's gonna be like just typical create, read, update, delete application. And we'll have authentication. So user needs to log in to see something. We will use JVT token to authenticate user. We will log stuff. And yeah, that's pretty much it for today. Let's keep it short and simple. Also, I prepared the file, which is encryptor. And what you can see here, I just predefined some stuff. We will use it for generation of JVT tokens. So first of all, let me quickly start and create the real base of our app. We'll just import Express. We'll have some ports. We will need body parser to parse the response.
Hello, Alex. Could you make the font a little bit larger?
Yep. Is it okay now?
Or maybe 2 times larger.
Even more. Oh, okay. Is it good now?
Yeah, I think
Can everyone see it?
It's better now. If anybody would like to have it larger, just note in the comment. Okay, thanks.
Okay. So next, we will start listening for our port. So it's, sorry, I need to create an app. We are gonna listen for our ports, and when it's ready, we're gonna log something. So let me quickly check if we can run it. So something is listening. Okay, let's create a first endpoint for our app. It's gonna be just simple get endpoints. And so let's have endpoint which will list all CLs we created before. We'll just have function which accepts request and response. And it will send an array CLs. For the sake of testing, we're not going to use any front ends. We're going to use Postman. If you never used Postman before, it's a library which, not library, application which allows you mock and send a request to server. So we'll create a new request.
Of course, in Electron.
Yep.
Could you also make it larger, the window?
Yeah, surprisingly I can, yeah.
Ah? Okay. First, maybe.
Yep. Okay, so we have port 300 and we're gonna send request for our list. It was a name and we're gonna save it to Node.js meetup folder, and yeah, we're gonna send request for the list, and I need to run it. Here we go. To make it faster, I'm gonna use Node.js package which is called NodeMon. It allows you to listen for changes when you're working with Node.js. If you never used it, I really recommend you. So if I will change something now, it's gonna be reflected in my codes quickly. So I will change text and let me send another request, and yeah, it's updated, so I don't have to refresh it. So we created some endpoints. Also, we will have to add additional resources. Let's stay with just post. Which we will use for adding additional entries, and delete. For deletion, we will need to specify what we want to delete, so we'll have some ID. So we have boilerplated this stuff. And at some point, we will have to think how we store data. It's the first moments when you realize that you need to have some infrastructure. And you start thinking about, so probably I need to use some database, how I will deploy it, how it's going to work on different platforms, how it's going to handle different database versions. What if I want to pack it in Electron, where I wouldn't have access to all those classical databases? And let me talk a little bit about data layer and what we can do with it. So let's switch back to our wonderful presentation and talk about the storage. We need to think and honestly agree on the fact that we are probably not going to expect much users. If we are building something small, if it is a prototype, or if it's an Electron app, which is automatically like only one client's app, if we're going to have some smaller websites, some smaller app, chatbot app, probably we won't receive as many requests. And when I'm talking about not many requests, actually, I'm not saying that you can handle 5, 10, 20 users a day, but I'm talking about hundreds. And actually, I measured it. I'll show you some numbers a little bit later. But if the answer for your questions is numbers and you are not doing any complex calculations on the backends like machine learning or video processing or even photo processing. Like if you just manipulate this data and give your customers some information, you can easily stick the non-concurrent databases, one of which we will choose. Also, you need to think about normalization rules, because for some complex apps, from the business logic perspective, it might be easier to have proper databases where you can have make joins easily, or you have to store different data, historical data, because if we're gonna use some non-concurrent file-based database, it will become as smaller and smaller as longer you use it. So it's important point to focus on. And security and encryption, solution which we'll cover in this talk isn't as secure, and if your files on your server were exposed, your attacker might get access to the database as well. There are some workarounds which make situations like this more unlikely and makes it harder to compromise your database, but still it doesn't make this impossible. So take in mind the fact that you probably need to store less data and be more careful about what you save and what you don't. So there is such thing as file-based databases, and I was very skeptical about it, since I had thoughts like, okay, I have many users, but I have one file, and if I'll just write something to the file and take the data out of this file, I'll probably get some concurrency issues. Like, okay, I'm not gonna have like hundreds of users simultaneously, but I might get just 2 users who will use the app in the same day and in the same moment. And I was always cautious how I can handle such situations. And surprisingly for myself, I discovered that there is a market of such databases, various packages, various libraries. And I gave it a try, and it worked perfectly well for me. So I decided to share it with you. I'm using the package which is called LowDB, and what it actually does, I think I can demonstrate you. Before showing you the package itself, oh no, I exposed my presentation. Give me a sec. Yeah, here we go. So what you actually can do for storing your data is simply, please don't use it on production. I'm just doing it for demonstration purposes. So this one is leftover from my first run when I tried to do so. So let's imagine we have some file system, and every time when we access this endpoint, we will create some random number, add it to our database, and return everything what we have. So let's get random number. Let's take everything what we have in database now. Let's create the file so we don't have to handle like, does the file exist or not? We want to keep it as simple as possible for this example. So we're going to do it synchronously, so it's easier for us to handle it, and we write less code. So we have this file, db.json, encoding is UTF-8. And we want to parse this from the JSON. So let's call it db. Forgive me for calling this db, but yeah, JSON parse file. And afterwards, I want to add this number to our db. So I want to save it back. db.json. Afterwards, I need to write some data. It's gonna be JSON again. for DB and encoding. If I did everything correctly, which is, oh yeah, and we want to return DB, which is kind of unlikely. Let's check if it will work for us. We generated a number. Let's check if it is in our database. We got this in our number. Let me send another request. We got 2. So we created something, and if we go to the database, we can see pretty much all the random numbers we have generated. So it's not in memory already. And if I'll shut the application down, oh, no. Oh, yeah, that's good. That's good. It's not that screen. So if I'll shut everything down now, even though it's actually has been restarted, I'll just do it explicitly so you can see that.
Could you zoom in the console?
Yeah, you should see the console now. I restarted that.
Yeah, but could you make the font also larger there?
Oh, yeah.
And the postman full screen.
That's a really good point. Can you see it better now?
That's better.
Thank you. So let me switch back to the postman and push it again. So you can see that we persisted the numbers. And because even though we removed our app, we have some persistent storage in our database. This conception is staying behind all those file-based databases. And you might ask me the same questions I pointed at the very beginning, like what to do with concurrency, and if it is a good way to do stuff, why other people don't do it, and why it sounds so crazy and stuff like this. And well, it is not as performant indeed, but all databases are actually file-based in one way or another. There is no some magical entity in computer which saves your data somewhere in more accessible way. What is actually happening under the hood is that you have some structured data which is more optimized to access. It's often pre-cached in your RAM, so you don't access file storage as often. But idea is still that you have all this data stored somewhere, somehow on the file system of some server. And for a small app, we can neglect the performance advantages of traditional databases and use something easier and simpler, which will reduce our development cost and which will make our application much faster to deploy and check. Second one is concurrency is a bottleneck, but it's not gonna be a bottleneck in data losses or data corruption, but it's gonna be a data loss. I'm sorry. Was in execution time. So security suffers, but there is encryption. Many of file-based solutions come with some encryption, which allows you to kind of encrypt the JSON file. And if you put it somewhere far, far away, you don't need to worry about, well, you need to worry about, you worry a little bit less about this file being corrupted. DB is a part of code base unless additional measures are taken. And you will likely want to take those additional measures because if your app is already in production and database is populated, every deploy you have the conflict and you don't want to override the database on production, obviously. So you will have to merge conflicts. And if you made something locally, tested something locally, it's not gonna work automatically, I can promise you. So you will want probably to put database in some separate ways. It might be also a Git repository. You can easily backup it in another Git repository, but there is no actually restrictions for you putting it outside of the primary Git repository. But what we get is that it's configuration free. We can do it on any server. Again, the only dependency what we have so far is Node.js runtime and bunch of JavaScript packages which we installed with our Node.js. So we don't install anything what is really platform dependent. So you can run it either on x86 processors, you can either run it on ARM. And I mentioned that we used Raspberry Pi for one of our projects. So it was really important to track which packages are like pure JavaScript packages and which packages actually bring some binaries inside of them. So you probably want to see some numbers for me being more convinced that you can store data in files. So I think I got something for you. And there is a package which is called Artillery. For sake of keeping this presentation in some reasonable time, I will just show you the results I did for the similar experiment, but with real file-based database. I will show you how it works. File-based database, but about results. Artillery is a package which allows you to send a lot of simultaneous requests from different users, imitates like one user sends requests after another and configure that, okay, I have 20 users, each of those users will send 20 consecutive requests. And it will allow you to measure the mean response time, the minimum response time, maximum response time, and quarters. So we can understand more or less how your application performs on the different loads, on the different endpoints. So you can do it easily for targets machine by just getting Docker and limiting resources in Docker configuration. So you can set in your Docker config that I'm gonna use like 1 GB of memory and like 1 GB of swap or something like this. Make sure that you have enough resources so Node.js dependencies can be installed. It's the biggest bottleneck for me because when we worked on Raspberry Pi and we had Raspberry Pi 0, it wasn't capable of installing dependencies for itself. So we used another Raspberry Pi with bigger RAM to install dependencies and just copy it, pasted it to smaller one. Get Node.js Docker image. It should be enough, and you don't need to learn deeply Node Docker if you don't want to learn it, and attack it. Actually, it's all gonna look like one command from the console. You specify the URL, parameters, how many users, how many requests, and you can see some results. So what I got, I created a Docker image and restricted it to have one CPU, 1 GB of RAM, and half of gigabyte of swap. It was just basic Node.js image. I created app. This app was doing actually something similar to what we were doing with random numbers. So it was a URL. Each time you access it, it reads data from the database, adds additional value to the database, save this data, and returns the result. So I decided to measure if the file access is still a bottleneck if you use normal machine with normal SSD, because SSD makes a big difference now, and it allows us to reconsider if you want to use file storage for small projects. So what you can see is amounts of mean response time in the milliseconds on the vertical axis, and amounts of requests I thrown in it, actually amount. So you can see that when I just read data from the database, just access file and throw everything what was in file out of this file to the client, the request time was really small. It's something like 2 or even less milliseconds per request. But again, it's all located on my machine. That's why it's so fast. I didn't have to spend time or network expenses on remote server responses and stuff like this. When I had to get request, when I've been throwing requests and I've been actually reading data from the database and saving it, but every time I've been saving another value without accumulating itself. So like I got value, I saved something to the database, but I didn't increase the size of the database. I got also quite acceptable results. And I got something like 6 point something for milliseconds for 800 requests, which is also pretty good. But as we know that devil hides in details, and when I tried to keep data in the database and keep it increasing, you can see that amounts of response time also increasing. And it's something what you need to count on. If you're gonna have like thousands of entries, it's gonna be kind of significant slowdown of your average response time. And as bigger as your database becomes, that's lower it's gonna be. So let me show how we can do so, how we can use file storage for the database and how complicated or easy it's gonna be for us. Give me a sec. So we got our code again. And let's make it a little bit more comprehensive. We will use a package which is called LowDB. It's a library which allows you to access file storage database. I'll remove what we created, so we don't need this anymore. We also use adapter because you can store data in different places with ODB adapters. You can use RAM exclusively to store your data and make it highly accessible. You can use it for as a file. There are also adapters which allow you to use it in Electron or React Native, so you can store files in device memory. What we also do, we construct our adapter. We specify which file we're gonna use. It's gonna be db.json, as like pretty the same what we had before. We have this database which is constructed well, and we define what we're gonna have. Like instead of items, let me have seals. Performance is left over from what I had before, so we will have seals and users. I mentioned that we're gonna have some authentication here, so let's keep both. What it does, it will check if there is a file which is called db.json, and if there is one, it will check if there are like such arrays, such properties, and if there are unknown such properties, we'll create them. So that's one is done. Next, let me import this stuff to our app. So I'll call it slow. And let's do the same what we did before, but instead of saving it directly to the database, we are gonna just save this data to using like our WoW. So let me remove all this stuff. We don't need this anymore. So we generated the number. What we're gonna use, we're gonna have this WoW get seals. Seals is the array which we will create during the construction of the database. And we will just push the number in there and we'll write it. You can do some intermediate actions when you're working with database, and it will be kind of similar to some, well, a little bit similar to transactions in classical databases and SQL, but yeah, it just works fine for our needs. Since now you can see that our nodemon went crazy and we probably want to ignore it, but as for now, I'll just restart it manually. While it is happening, it's listening for changes in our folder, and database is updating. Every time it is starting the app, we touch in database.json, and that's why we get this interesting situation. So let me start it. We got it's up and running again. And let's go back to Postman, send request, and yeah, it's not working well. So There might be reasons behind it. Yep, and there are obviously reasons behind it. So in the first place, I wanna get the value out of the database. So this one will return everything what we have here, and this one we will use for saving data. So we sent request, we saved something to the database. One more, one more, one more. So we got the same using ODB. And now we can try to create something more meaningful. So let's finally make our app more or less useful, and let's make our endpoints behave like real endpoints.
Okay,
So,
Alex, may I interrupt you?
Yep.
Just to ask in which percentage of the presentation we are, just to make sure that we
I
will
think we are halfway.
Yeah, just want to make sure that we'll have the time to make this AWS stuff too prepared.
It's not actually AWS stuff, but yeah.
Okay. So
yeah. So, Cesare, tell me if we'll need to have break, if it makes any sense for us, or we'll just go.
no, I think we can go forward. Just like to recognize where we are.
Okay. Then let's remove this stuff. For get endpoint, we just want to have the list of values, so we don't need this. Let's name it more reasonable way. We also want to have some endpoints. To have this endpoint functioning, we'll have to use body parser. So we need to do something like this. I believe like this. And then in post request, we will be able to access data from our body. So let's get I think one property just enough for us. We'll have name. We'll generate some ID for some name, and we'll generate ID for this entity so we can save it. I believe I have this as a snippet. Give me a sec. Yep. So I will save a little bit time and just duplicate it. So we will have something like this. We will generate an ID and we will save the name. So this one is going to be the form of our data, and we'll put it into our storage and we'll write it. I will skip validations, checking if we receive empty value and stuff like this, because it's evening, everyone wants to spend time with their families, and I don't want to take it from you. So we got an endpoint which will save the data. We want to resolve requests. So we'll just say that's fine. So let me remove the existing database because we don't need it anymore. We got different data structure. Let me minimize it a little bit so we can easily switch between windows. So we will restart it. It will instantiate a new database, and let's send post request. It's gonna be the same endpoints, and we're gonna specify body. It's gonna be row, and we specify that it's JSON. So here we go. And it has been failed. And so obviously, I think I misused body parser in some way or another. Oh, that's a pity. So here we go. We send another request, and it's failing again. We need to import short ID. And yeah, let's do so. And let's send it again. Okay, we actually sent something, and it says okay. And I clicked it a couple of times. We don't have any validations if we save the same data a couple of times. So if I go to the folder and we check database JSON, you can see that, woohoo, we got the data. So we got some COs, we got the name, we got a couple of them. I'll manually drop the one which we don't need. And let me send request get just to see that, yeah, we received this data. And you can see that even though I removed the data from the database, it's still there. It's the way how ODB optimizes the requests. It keeps it into the RAM, so you don't spend time every time on accessing data and reading data from file system. You just write it wherever you need, but you still keep the recent data in your memory, so it remains fast. So if I restart, it's now it's good to go. So we got get endpoints, and let me quickly make a remove delete endpoint with you. So I'll just quickly copy paste it so we don't spend time on it. We don't have items. We got COs. When I did test run, I just called it, I just called it items instead of COs. Yep, so we got ID, we got, again, COs, we remove it and we write it back, and we send to our clients the ID of removed entity. So we got one entity, we want to remove it. It wouldn't work because we don't use nodemon anymore. We need to restart manually. And so let's go back to the postman, switch to delete. And we got this ID sent. And so let's get it again. And it's empty array. Let's post some data. We got this list, we got body. Let's get some more meaningful names. I hope I got Polish naming fine.
Yes, it's fine.
Yeah, so we got this data saved. So we got basic root. I wouldn't do update, but it's actually as easy as delete. Let's keep it smaller, slimmer as for now. So what we got here? We got a couple of endpoints. We just use simple methods around, like, simple abstraction about accessing database to the storage in the file system. We got this db.json, and this works pretty good for us. But
sorry, you can repair it because it should be Grzegorz. So the not Gregorz, but
oh
Grzegorz.
yeah, Grzegorz. Yeah, we can send one more. We can send one.
Okay.
At least, yeah, it was a good intention not to write a surname. Okay, so yeah, we got one correct one and one incorrect one. Let's keep it as it is for now. So let's get to to the points how we can authenticate us. And what I like in Express is the way how middleware works. And actually everything what you have in like your app decorations, like delete, get, those are all middlewares, except the first arguments. Everything what you have after it is actually a middleware. So if I'll specify some function here, it will be executed. And if I trigger like next, it will go to the next function. Here I can also specify next and one function afterwards. So it can allow us to write some code which will reuse. And let's create a function which will check if we are authenticated. So let's call it authentication middleware. It's accept the same arguments because again, those functions are also middlewares, so easy to remember. We get our token. We'll store it in the header. It will be called token. And yeah, let's just check as for now if it's something what we want. Then it's next. And otherwise, we wanna say that, sorry, bro, but you are not going here. And let's use it in our endpoints. In order to save time for modifying our request in Postman, I'll just apply it to get request. All other requests will work without it, but again, it will be as simple as it's gonna be for get request. So we have get request, we send request. It works because no nodemon, we need to restart manually again. And yeah, that's going here. Okay, let me add a token, headers, token, oh no, token. Next isn't defined, yes, because actually I didn't define it indeed. Is the third argument, and oh no. So here we go, attempt number 2. It's still error because you need to save files after you change them. Okay. Attempt number 3, we got it. We change token. It doesn't match anymore. You're not going here. Perfect. To make it more meaningful, we want to save our customers, our users, so we can allow them to register. So it's going to be post endpoint, which will allow them to register. I will make some small copy pastes, so I write it less. We're gonna get some login password from the body, the same like we got data from our previous request. We want to validate if this data is empty or not. We'll keep it for the next step. And we also want to check if this user exists. What we gonna use here, we will go to our create variable if this existing user and go to database, and try to find user by login. And if there is user with such login already, we don't want to create one more. So we will just send that, sorry, bro, this user already exists. And otherwise, we'll generate the hash for the password. We don't want to store passwords in the clean way. We'll generate ID for the new user. We will create the new user. So we'll actually the same what I showed you before. So we will just access users. We will push and we'll have like login, which remains the same. Instead of password, we use hash and we will compare hash. and ID. And we write it. And the last one, we need to say that something happens. We'll be just notifying that, okay, there is ID. So this is ID of new user which we have created. You probably noticed that the function generate password hash hasn't been created yet. And I would just copy paste it now, since actually it's quite basic stuff. I'll quickly comment on what it does, but it should be simple. So before all our Express stuff started, we got a function which accepts password, and it uses crypto. Crypto is just default Node.js components. It's not dependency, third-party dependency which we have installed. We will just create hash. We're gonna use SHA-384 algorithm. We'll update it with the password and digest as a hex. That's it. So we did all this stuff. And so let me try to register our customer, restart the app, and try to register. Obviously, we don't need token for this request, but like anyways, it's gonna be ignored. Instead of name, we have login. I'm better now. I remember how to write it. And passwords, we'll use very secure passwords for this one.
Forget to make admin key also.
Whatever you want, whatever you want. So we'll send the request, and I can completely imagine that I miss. Oh, no. So it is there. It is post. Oh, okay. My fault. So we will send it as a post request. We send it, and we got an ID. It means that actually our customer has been created. And let's go to the database and check it. db.json, and we got users, login, password, ID. In order to authenticate our customer, we will need another endpoint for login. So we go here, and what's next? Yep. Let's create. Oh, no. What the? It's also going to be post. We'll have login, request response. And I also will be copying pieces. So we'll have the same properties. So we'll extract login and passwords. And yeah, by the way, it will make it more readable for us on the smaller screen. I also throw away the validation for login and passwords, since we don't really need it now. We'll need to generate hash straight away. We'll check if this user is in database, but unlike this verification which we had here, where we just checked if our user exists in general by login, we want to compare the whole combination of login and password, but not password, but hash. So if there is anyone with matching fields, it means that passwords which you entered is valid, and we can authenticate our customer. So for this, we will generate token. It's not like REUSABILity simplified it for purposes of our presentation, but we'll have two fields, expiration and user ID. We need expiration because we don't want to have tokens which allow users to stay permanently if their session was taken by someone, sniffed, we don't want to have those tokens be in a live for a long time, and we want to make our customers to log in a couple of times again. There are different strategies how you can do so. You can update JUT tokens on consequent requests, so customers don't have to enter credentials all the time, but they get tokens. But we'll just keep it as easy as we could do it. And another one that we need to make it a token, because if we'll just return it like this, everyone will be able just, okay, I'll type some user ID here and I can pretend and behave as this user, which we don't really want. For these purposes, I will use those encryptors, which I showed you in the very beginning of this presentation. And I'll just import those two functions, encrypt and decrypt, to our app. Here we go. And also I pre-generated some security key, which I'll just also copy paste. It's just 32 digits, and we'll make buffer out of it and pass to generator of our token. So yes, so let's encrypt it. I also copy paste it so we don't spend time writing in it and reminding how it works. So encrypt functions accepts object, the one which we wrote here, and our secure key. So now after trying to login, we should receive our token, which we can use to authenticate. But as for now, it doesn't mean really anything. So we want to have it used somehow as a part of this function here, so we can validate our token when the request comes. For this, we'll do something like this. In the first place, since we don't know what our clients will send us, and if we can decrypt the token, or probably we changed our security key at some point, and we can't decrypt previous keys, it all will throw errors, and you can either handle the inputs and make sure that it's not encryptable, decryptable, and it's valid token or not. But for our purposes, we can do try catch. And what we're gonna do, we wanna know what the error was, so we will walk error so we don't miss it. But also we will send response. Actually, I could have just copied it from here, which would be much faster. And of course, we don't want to go anywhere else. So that's the first place. And another one is that we want to know what client it was. So first of all, let's get parsed token. This one will decrypt it into JSON. We won't get an object out of here, so we need to parse it. And it's actually a second place where our app can break if we encrypted something wrong and it's not JSON. So we also don't have to have explicit checks if it's JSON or not. And then the last part, we validate if our user actually a user and it has ID, which I called user, which isn't as good. And yeah, we just specify in console what it is, and we allow our app to go further. So let's try it out and see which syntax errors I made this time. So we got our register, and my login is Grzegorz and password is admin. So let's go to the login. Actually, I will just change this one so properties remain. In the first place, I will try to log in with the wrong password. So
very wrong.
Very wrong, yes. Well, at least I was right that I'm gonna have some synthetic errors. So request params ID. wait, probably it's not the one, user dot ID. And fast forward. Did we store IDs for our users? We did. And why we don't have it? Oh yeah, that's my fault. I forgot really important piece. If there is no user, we cannot log in. So we have this. You're not going here. We put it to our login. Here. Probably like this. And let's try again. We got it up and running. We send requests. And it is saying us that we are not going here. We replace the password and we got token. We got list endpoints. We send requests, which doesn't work because our token doesn't work. We replace it to working endpoints. And yeah, it worked. Surprisingly, I expected like more errors. Actually, there are some errors in the cryptor, but because we have this try catch, we can skip them for now. But you can see, okay, there is bad input string. And actually, this one was the reason because we sent like this 1, 2, 3, 4 originally, which couldn't be decrypted. And another one is because I didn't write return statement somewhere before, like after sending the error message. But okay, let's keep it for now.
Okay, Alex, I think we need to go somehow to the conclusions because after 7 p.m. we start to losing the active watchers for that.
Yeah. That's fine. No, I mean, that's not fine, but we are going as schedules. I mean, since it was scheduled for 2 hours, we are on our way. So my points of this is that we started doing it less than 1 hour ago. And as for now, we got a working prototype of CRUD application where you can log in and log out. And it is all done not on the mock, but on the actual data structure. So we have it here and it works fine. And you can use it as a boilerplate for your app. So let's back to the presentation and talk about it a little bit more. You might think about scaling it, and unfortunately that there are so many ways to scale it. Node.js is multi-threading now, and we had a talk about this on one of our Node.js meetups. You can have more threads, and it will slightly increase it because of internal event loop optimizations, but still not as dramatically. It won't speed up your reading from the file system because still you have write and read, and it's a blocking operation, and amounts of threads isn't the bottleneck here, but access to your hard drive is. But aside of that, yeah, that's it. Concurrency, yeah, we have event loop inside itself. It takes care if you get a theoretical situation about this, like when you come, sorry, when you have a couple of users which access your website simultaneously, they wouldn't corrupt data because it's blocking operation and ODB is synchronous. All accesses and readings, writes from ODB are synchronous. That's why you wouldn't have data corruptions problem, but you would probably have it more. Accessing data structures and updating it is also synchronous. So if you have some your own objects and arrays, you wouldn't be stuck. You wouldn't have it corrupted. You would be stuck, but you wouldn't be corrupted. So let's talk a little bit about deployments. That's really unfortunate that we started losing people by this moment, but actually it's quite a smooth part.
Yeah, so let's wait for that.
Yeah. So in the first place, I mentioned the architecture where you're deploying, and it's something what you need to think about. If you want to deploy on some servers which are not the same architecture as your machine, you would probably consider packages which don't have binaries inside. You will use deployment scripts for this, and I'll elaborate on it right now. And Git hook subscriptions. Um, Unfortunately, you have to have additional manipulations to know that your Git repository has been updated. And how actually a deployment process works now is the reason why actually ops engineers exist and DevOps engineers exist is like modern CI isn't as easy and there are many bottlenecks. And probably you don't want to have it for a simple projects, the projects which we are talking now about now, and probably you want to consider something smaller. And if we make a couple of steps backwards and think about ancient times, it was fairly simple before like all this Docker stuff appeared. How it actually works, you had some endpoints which was pushed by your Git provider, like all those platforms like GitHub, Bitbucket, GitLab, whatever. They push a special webhook, which is actually just an endpoint, and they notify you that okay, there is some change in Git repository. Your webhook triggers pull of the changes from your repository. It installs dependencies, builds the app, and it does it in a separate folder. It doesn't replace the folder where current app is running. Afterwards, you run tests. You make sure that everything working fine. You kill the previous one and start the new one. In languages which are not compiled, like Python, like PHP, it was usually just done by changing the symlink. So you had some like kind of app folder, but it wasn't a real folder. It was symlink to one of the deployment builds. And when you finished testing another deploy build, you just change the symlink. You can do something like this for Node.js, and you can just kill one process and nodes another process. So it's actually what's working fine. You can adapt it for your needs. You can find the implementation of endpoint for Git updates can be found on the websites of those platforms because they are very specific for GitLab, GitHub, and stuff like this. Or you can just trigger checks manually and pulls manually once in a while on your server. It doesn't really cost much in terms of network, in terms of resources, and just update it wherever you need. You can do it manually, but this simple flow can be easily implemented, and it works for smaller apps now. So when you have everything contained together and when you don't have any side dependencies, you can stick to this schema and deploy your app without additional overhead. It comes with some security issues, and one of the thoughts I'm constantly having about it is that I'm not a security engineer, I'm not a DevOps, and probably, and not probably, but absolutely, probably, I'm gonna have problems with that. There are definitely some things I don't know about in terms of security, and it would be really ignorant to assume I do. And what you can do is try to protect yourself as radical as you can. First of all is input whitelisting. So if you have logins, passwords, and you know that you can enforce some certain strategies on what can be there or couldn't, you just whitelist, allow characters, minimum and maximum length of the string, and do as many validations as possible, escape the string, but you try to make sure that there isn't anything what shouldn't be in the database by really strict restrictions of what is going there. One bonus points that SQL injections are impossible without database, and when you're using your file store database, it's actually one positive point of it, but as I mentioned before, if your file system has been compromised, your database is compromised as well. So it's kind of parity. Don't store something if you cannot protect. And I think it's the most reasonable strategy here. We are talking about small apps. We are talking about prototypes. And of course, data is a new gold or whatever. But do you really need all this data now on current stage of your app? Do you really need it? Because as less you store, as more your responsibility becomes, and as small risk of big damage to you and your project happen when it actually happens. Overload protection is something what you can do with configuration of your server. Make sure that the same people don't send tons of requests simultaneously, don't break you up, and you can handle this. And one more thing, that all those small apps, they're quite obscure, and when people are trying to compromise you, they don't really expect you using something that simple and that specific. So some vulnerabilities aren't the case when they use this kind of architectures. But again, it's more just some positive thought about it. Security by obscurity isn't considered by as like viable security measure, but is considered as a good addition to other security measures. You need to make sure that your app is also fault tolerant, because if you get an error, you don't want to have your app down. There are a couple of process managers. Some of them help you to leverage multi-threading, like PM2. There is another library which is called Forever. I used it when I been developing chatbots, and it was quite handy. And I ran my script with Forever, and I forgot about it for about a year. And afterwards, I discovered, surprisingly, it was still up and running, which is really cool.
That's true story.
Yeah, so Forever, I mean, first of all, not FM2, but PM2. Sorry, I misspelled it. But those two packages, from fault tolerance perspective, quite similar. PM2 is much more advanced. Forever is just more utility, but they just do its job. You need to think how you log crashes. And well, one of advices, don't store logs on machine which produce logs. In case it dies, you don't know what happens. So there are a couple of services. I wouldn't focus on it since most of the services are paid, and I didn't find anything good and free simultaneously. So if you have anything else, suggest in the comments. But yeah, just use some services. It's really helpful, and it works. Usually you just save post request to some API, and it just stores your data and helps you to navigate, sort, filter out stuff you don't need or need. How to get notified about issues, it's also something you can get as addition to those logging services, some notification about what is happening, and think about the ways you handle it. For example, I don't react to emails anymore, and it's hard for me to make email work for me. So I decided that for notifications, I'm going to use additional channel. And for myself, I use a Telegram bot, which notifies me about my fault issues. But you can use whatever you want. You can use SMS Gate. You can use bots. You can create separate email app, separate email address, and
Slack,
sure
or maybe Discord, or maybe Mattermost also.
Yes, many different options, but don't rely on customers which come and tell you that your service doesn't work, because they wouldn't really do so in most cases. So that's about this. And I wanted to call it quick wins, but actually it's better called cheap wins, as much as everything this presentation is about. In the first place, add database to git ignore and backup it another way. I mentioned it before, but storing database in the same repo as the code base isn't a good idea from many ways. from security perspective, from merge conflicts, from backing up the database separately from the code base. So put it somewhere outside. You can manage it in configuration of your server and make sure that it's working fine. Don't keep data you don't need. I told it probably 3 times already, and I can't stop telling it. One of the best way of protection data is not having it. Escape all input data as much as possible. Again, you don't know all vulnerabilities. You don't know where the problem is coming from. Lots of problems are the results of server configuration issues, and I was I had problem with it once in the past, and I did many mistakes there. I had different websites running from the same user, and all of those websites were compromised, and they got some code injected. It was really painful to clean it up, and it was really painful to explain people what happened with their websites, because I've been hosting someone else's websites. So yeah, even though a lot of problems are network problems and configuration of port forwarding of SQL, different admin panels and stuff like this, escaping data is something what you probably want to have. Split into functions from the very beginning, since again, functions are easier to move to separate file, functions are easier to test, functions are easier to compose. They are just small pieces representing the business logic in your app. And just keep this way of thinking that if you can copy function into separate file and import it in another file and it doesn't break the whole flow, then it's quite good function. Cache responses or pages, it's also a good topic to talk about, since you want to keep it performance, and if you have big sets of data which require you accessing different files or making requests to third parties, parsing different web pages and stuff like this, you want to probably have some intermediate cache. You can use your local database for this cache and put data which you received from other sources and just update it. There are different strategies how you can handle cache. You can automatically refresh data for cache once in a while, or you can warm cache by customers. So when customer access an endpoint, if it was accessed recently, you give customer a cache. In case this endpoint hasn't been accessed before, you do all the operations needed for receiving this data, give it to your user, and also put it in cache, so it's cached now. But it all depends on how complex the calculation and how process of obtaining this data is. That's actually it. We did it less than in 2 hours. And if someone is still staying with us, thank you. Thank you a lot. Feel free to ask any questions about it. I can stay here, talk about it, or write your questions in the comments on the YouTube. After watching this video, I'll also try to answer everything I see.
Okay, thank you very much, Alex. And also just give you some time to write your questions, write stupid, silly questions. All after all, they will be smart as usual. So don't afraid. And yeah, from my perspective, maybe I will be not the best debater, because I agree with you with your approach with the tech stack, with the, say, reasonable approach to functional programming, not that much orthodox, and all of the tools that you mentioned. So also beside the presentation about monads that you linked in the presentation, also on our previous meetups, we have the tools, present the tools that you mentioned, like the JSON Web Token, Cypress, and also other stuff. So yeah, that's very useful things. But one question that I would like to ask you is, as the topic of your presentation is why so hard, and just showing that when you're writing the just smaller apps for your own, or for some very specified tasks. Let's just don't make it harder, don't make it more difficult. But from your perspective, are all those highly scalable commercial apps, do they need to be that hard? There's no way to write it simple and divide it into smaller microservices. What's your opinion from your experience?
I think that complexity grows exponentially. I have no numbers to prove the word exponentially here, but it more or less reflects how it becomes. When your app become bigger, you want to have predictability. You don't want to have problems with more user success in it tomorrow than you expected. And you don't want to have security problems. So you can invest more resources into building something more scalable. I'm pretty sure you can make clusters of different file systems on different machines and build distributed database on top of it. But why? Because you'll just recreate something what is already a part of the bigger databases. In my personal opinion, clouds is a really nice way how you can avoid manual configuration of many servers, because they take care of networking, and it's actually quite tough to handle all this networking stuff, configuration, and knowing which services in your system have some default settings you need to know to remove, and you need to configure properly so you don't expose any admin credentials or ports which are not needed, or you have some SFTP shared access for people which you didn't know about. So avoiding like all this system configuration might be a good trick. Plus, it gives you a lot of tools out of the box. So the reason I gave this talk is exactly to encourage people to think in a little bit different aspect about building smaller apps where you can just quickly achieve your goals. In the business environment, there is a strategy which is called fail fast. And it's something what probably you want to have when you're building something small.
A POC for something.
Well, POC, MVP actually might be different stages. Also, there is such thing, it's called technology readiness level, and there are like 7 or 8 of them, if I'm not mistaken. So you can call it in different many ways. You can split the stages in actually different stages, but the goal here is that probability of the project failing is incredibly hard. Sorry, it's like red doors, incredibly high, and investing a lot of resources from the very beginning just to check your idea isn't the best thing. Some applications are not supposed to scale ever. For example, many chatbots might have quite limited audience. If you're building some service for lawyers in Wroclaw to provide people with open data for Wroclaw, you are not gonna have many clients to give you troubles, because you simply don't have as many target audience in your location. You don't really have capacity of any other users coming to you, because you don't have those users theoretically. So for those cases, it's completely fine. There might be different specific projects. And actually, you can use it for local websites, or not even local websites. I heard of a couple of different projects which are built with Gatsby, and Gatsby is a static website generator, but it works pretty well with this strategy. And again, you have really low tech server, you fetch the data, you compile ads, you compile news, you take data from some CMS, but for the end users, it's just HTML cache, which is easy to serve. It doesn't consume a lot of resources, and yeah, it can be easily served. So for apps which are prototypes, and for apps which are not supposed to be scaled, which have limited application, it's a good thing to go.
Okay. I see our users are still a little bit scared about asking. But one more from my side about the databases, because yeah, as you said, databases are just files, or after all, yeah. So even if we have some smart formats like Parquet or Avro, it's also all about files. But you mentioned this LowDB, which I don't recognize that much, but it's really popular. I even don't know that much, and for a lot of applications using Electron and so on. But you didn't mention the SQLite, which as I remember, in the early stages of Node.js, it was very popular, also on embedded. Do you have some experience with SQL? And what do you think about this SQLite stuff, in your opinion?
I think it's pretty much the same in many ways. Idea of SQLite is by having some file and providing the SQL abstraction about it. But from my perspective, it's just easier to use abstraction which is given by LowDB. There is no big conceptual difference, but rather preference of API and syntax which it provides. I like the way how everything is stored in JSON, and I can easily access this data from my editor. I can see what's happening and what I want to change there. So I think it's completely individual for everyone, and you can choose whatever feels easier and better for you to use. Because in the end of the day, we started from the statement that I use Node.js because I know Node.js and I feel comfortable writing in it. So the same is applicable, of course, to infrastructural things, but conceptually it's pretty much the same.
Okay, so I know, are there any more questions for anybody? Comments? If you have anything, feel free to add it to our YouTube link, because the link for the live event will be also the same for the recording. So yeah, exactly, it's here. Also, there is a link for the survey, which Marta or Elena from Data Art just pasted to our comments. So feel free to use it. Yeah, and we invite you as well to our Discord group, because we're also happy to see your presentations, see your comments, and what you would like to share with anybody else, or just give some topics that you'd like to hear about. So I also pasted it in the chat. And yeah, thank you very much, Alex. And I think we're giving the voice back to the data again.
Yes, thank you very much. Thank you, Alex, for this great presentation. And also thank you, Cesare, for keeping this community alive. And see you all at the next meetup. And have a nice evening.
Yeah, thanks so much. Just a few seconds of smiling until the recording will be stopped.
And then they smiled for an hour because someone forgot to turn it off.